Hi, everyone. Thank you for joining us for our session on thinking about transforming businesses generative AI. I am Pham, our Vice President of AI and Machine Learning at Workday, serving as our AI ambassador. And we have with us Shane Luke, who is our Vice President of AI and Machine Learning and our Head of AI and Machine Learning at Workday. I will kick off with a quick intro of Shane, and then we'll split the next 25 minutes into three parts. We'll talk about the history of AI and ML. We'll think about some risk, benefits, et cetera. We'll talk about some examples we have here at Workday to share, and then we'll wrap up in how companies and organizations can think about implementing generative AI in your own organizations. So we have with us Shane, who, as you know, is a leader here in AI and ML. And Shane has also founded a company that has supported software developers and has led product and engineering and AI at Nike in the past, and done a lot of work where he's paired together technology, product, and AI to not think about the depth and technical details of the product, but also how to bring the models and the technology into real use cases that work for people. So I'm really excited to get to discuss generative AI with Shane today. Thanks for coming.
Yeah, thank you.
So we'll kick off with, Shane, you've been in this space for a while. I think we had discovered that both of us in grad school had been tinkering with neural networks over 15 years ago at this point. And so AI machine learning is not new. Some of the large language models and generative AI is new. So can you tell us more about the state of generative AI, large language models today, and really what brought us to this moment of why we're in discussions about large language models?
Yeah, for sure. So like you said, the practice as a whole is not new and actually goes back to the 1960s. A lot of things changed between then and now, obviously, and we're on an accelerated curve. So between, let's say, 1962, which is I think the first neural nets were in research labs, and then up until the late 90s, early 2000s, you were really looking at all of AI as a research pursuit. And that's what I was interested in grad school. I never thought that I would actually work in industry doing anything in AI and machine learning. But we were using a lot of the same techniques. But shortly after that, what you see is this dramatic increase in some of the things that you need to do AI at scale. So one is the tremendous growth of the internet and data sets in general. So that has grown tremendously. 90% of the data in the world has been created in just the last couple of years. We saw massive growth in compute. And so we didn't have cloud infrastructure. When I was in grad school, we trained on desktops. Then it's an ironic name because we had to push them under desks to have enough room in like a dusty old lab. And that's what your compute was. So there was no option to take gigabyte scale data sets and train neural networks or anything like that. So we have that now, and we've had that for a while. Very recently, in the last year, we've seen this explosion in model size and this heavy investment in highly parallelized training of these models with very large scale data sets. And so if we look back around 2017, 18, the first of what we call large language models came out. Workday started working with those at the time. We worked in particular with BERT. The first GPT model came out around then. About 100 million, 120 million parameters. Okay, so don't worry about what a parameter is if that language isn't familiar. Just think of that as a rough sizing of the model. You go forward a few years and you get to 1 billion plus parameters with the GPT-3 model. Then you go forward and you get to 500 billion plus parameters. And up in the far right, we're at 1 trillion plus parameter models. And those really large scale ones are the ones that you see doing these kind of mesmerizing things with language. You give it a gigantic input and it produces a gigantic output that's well structured. You say, write me a song, and it can do that. You say, create an API for me to be able to do such and such functionality, and it writes software for you. So like these things, and I think that's, to answer the question directly, that's the big change that everybody is interested in, that you now see what looked like kind of interesting things, but a little bit esoteric for researchers to look at, or very specific applications. These language models are showing incredible generality in what they can do, and incredible length in what they're able to output. And I think that's why everybody got excited right about a year ago when ChatGPT launched. And ChatGPT also put this in the mainstream, right? People could now touch and play with these things where as an implementer and a practitioner, we always had insight into that, but now people could just interact with it and see what they could do. And I think those things have created a lot of excitement.
Thank you. Yeah, I think the history of how this came about is so critical as we think of our next steps and our different roles. Thank you for sharing that. So with that comes the conversation we often will hear in many of these rooms, our conversation about risk and benefits. So technology has moved at scale. We've had compute power, cloud, et cetera, change in ways that has now really enabled large scale access globally to not just the understanding of the technology, but people now building, externally building products and have a general understanding of large language model, generative AI has a different meaning within the enterprise context because we have much more structured private data. So with that comes the conversation of how do we think about risk and benefits? So let's just start there. How should we think about risk and benefits as a whole? Maybe we can dive more.
Yeah, so with any technology, you have to ask this question, and you have any computing systems at all, and you have risk, right? There's a risk of attack. Anything that you put out in the public domain can be attacked, and that's why you have security teams. That's why you have vendors that go and do audits on your technology, and it's not really different here in principle. So in principle, you're still looking at the same thing. But in practice, the types of risks that we're facing, there are some new risks, right? And so some of these risks are things like models outputting content you don't want them to do. So in particular with language models, there's this notion of prompt injections where like a skilled but malicious user could prompt the model in such a way to make it output content you don't want. And that could be something like toxic content or biased content. It could be something more whimsical, and there's lots of examples of people doing this with GPT on the internet at large. So there's some new risks to deal with, but it's still kind of the same type of threat landscape that you've always had. You've got a computing system that you're building into a product. You have ways that it can be attacked, and you have to try to mitigate those ways. One of the approaches that we're taking at Workday to be able to do this, to be able to mitigate these risks, is using models that use the same sort of architectures, the same techniques, and the same technology, but at smaller scale, tuned to be very specific to the task that we want them to do, or the set of tasks that we want them to do. So in a way, we attenuate the capability of the model in order to be able to reduce the risk that it can do something that we don't want when we put it out at scale. And so we talked about a use case recently that we announced where you generate career growth plans for employees. Workday does HR software. We have all these performance reviews, and most organizations are really good at doing performance reviews for people. They're not so good at doing the follow-up where you have to build a detailed plan to act on that review. And so generative AI can help you here, but there's a risk. We don't want the generative AI to be outputting something that is not a career growth plan, or something in the career growth plan that is objectionable or problematic, right? So we leave the control to the user. So that's another mitigator is the generative AI does not automate this process away. It does not create the growth plan. It just helps the manager or whoever else is responsible to create that by giving them a starting point for them to work from. It shows them all the sources that led to a particular recommendation, but it's also not a 500 billion parameter model that could write a novel for you. It's intentionally something that has lower capability, highly tuned to that specific task of generating a growth plan for an employee. And that's one of the reasons why we can show all the attribution of sources, because we have a lot more transparency into this smaller model. So there are a lot of risks, and you got to think about the benefits. If you choose not to do it, are competitors going to be ahead of you? Probably yes. People are going to be optimizing their supply chains. They're going to be optimizing their workforces, like that example. They're going to be optimizing their financials, which is another area that we are deep in. And so I think that with anything, the old saying, the safest place for a ship is in the harbor, is very applicable here, right? You don't buy a ship not to sail it. If you're in the AI game, you need to apply it. And in order to do that, you just want to take a road that mitigates these risks, and there's lots of different ways that can be done.
Let's pull on that thread a little bit more. You mentioned smaller model sizes, larger model sizes. For those who, having followed some of the external news, I think OpenAI recently launched, they stated that they had a 128,000 context window. They can analyze 300 pages of book, which ultimately leads to folks thinking, well, what are some of the use cases for that? Can you explain more for those who might not be as familiar with the details of smaller sizes, larger sizes, and what really is empowered by a smaller language model?
Yeah, I mean, there are a few areas, and some of them are not related necessarily specifically to the ethics front or objectionable content or safety. For one thing, running these models at scale and deploying them in a real production setting, smaller models are much easier to manage on all fronts. So you have a really large model and you want to retrain it, well, good luck, you can't. And that's why you have checkpoints that are, OpenAI will publish that, hey, it's up to date up to such and such a point, which is months in arrears, because they can't retrain it all the time. So from just an operational standpoint, efficiency of inference, all that kind of thing, smaller models are better. But when you look at why a smaller model is a better match for a lot of these enterprise use cases that we talk about, it's for the reason I mentioned before. It's targeted at that specific thing. And when you take a general model, if I go and we actually have really good research results to show how this works. If I take a highly generalized model, let's say GPT-4 from OpenAI, and I ask it to generate a career growth plan, it will do a pretty good job of generating a career growth plan. It's pretty good at that. I can also ask it to compose a novel for me, right? It can do all these very highly generalized things. So at that really large model size, they're encoding huge amounts of information, and we don't need our AI to write a novel for anyone. And if you're using it in an enterprise context, that's probably not something you need either. And so one reason to do it is you make it efficient, you shed off all the capabilities it has that you don't actually need and aren't going to use, and then you just take the portion that you want. And this can be done in many different ways, so we use a whole bunch of techniques for this. When you do it, you don't end up with lower performance. And so when we compare the performance results we get from a tuned, much smaller domain-specific model to a 500 billion plus parameter model from Google or OpenAI or somebody else, we find that once we've tuned it, they actually perform better. And so that's the reason to do it, and the reason why there's not really a downside to doing it either, other than the work that it takes to get there.
There's another thread I want to, whenever I talk to Shane, there's so many threads I want to pull on because he's a wealth of knowledge. There's another thread I actually want to pull on, which is around, you mentioned knowing about capacity. So how would different organizations think about, running large language models is expensive. If you just throw a very small problem at a really big model, you might be trying to spend way too much money on something where you really needed something much smaller. What are some techniques for really thinking through what kinds of models we really should be utilizing, and how do we even suss that out?
Yeah, so this is a very fast evolving space. And if you are getting into the game and you're thinking about how to predict what costs are going to be, you should know there are going to be pretty big error bars on that. And so the approach that we've taken is we start with a pretty wide open aperture, and we start with experimentation. And most of implementing AI and machine learning is an experimental art. It's not something that you can have a perfect plan for, that you know every aspect of what it's going to look like once it's operationalized. So you start with some goals, let's say. We usually start with pretty large model sizes, run them, we profile them to see how much they're actually costing. Then we start optimizing and downscaling the models with a particular target in mind. What we find is that, as we're doing this, this is the fastest pace of evolution that I've ever seen in the space, really in technology in my career. I'm more than 20 years into my career in technology. And so what we're seeing in addition to whatever plans we have is your plans are going to change very regularly, because the open source community is going to drop something out there that you want to now adopt or is better than what was before. Or it could be something that you discover yourself as you go through the implementation process. And so one thing that you do have to think about if you're going to do this at scale is that the way you want to do planning as you evolve your product and you're thinking about the unit economics of actually running these things in a real production setting and so on, is that you're going to have to deal with some uncertainty if you want to get the best result. If you want to be aggressive about implementing these things, getting powerful capabilities, things that could scale across many use cases, you have to accept quite a bit of uncertainty. That said, though, the tools are evolving so fast that you're going to have a lot of capabilities as you go too. And so I think of one example of this. There's a particular technique called LoRA, which stands for low rank adaptation. It's a way to dynamically change a model at what we call inference time. So inference time is when you prompt the model and it gives you back some content. Well, you can train a model on a whole bunch of different data sets and then change how that model is actually oriented right when the inference request comes in. And this wasn't available when we started doing development. We kind of thought we'd have to have a model for each one of these things. It's like, no, you don't, because you can train the same model on many different data sets that are completely segmented and then load those weights to the model at runtime. And it's an example of something that we wouldn't have known how to do when we started. We learned how to do it because the community developed that as we went along, and now it's part of our ecosystem and what we're going to deploy at scale.
Thank you. So shifting a little bit, but pulling on other threads you've brought up so far, actually with safety and the risk piece. It's actually Integrity Week at Workday this week, where we're focused on responsible AI and integrity. Our tagline is where innovation meets integrity. And I want to pull on that thread now of responsible AI. You and I had talked about how it's important and interesting to have governance, and we talk about regulation a bit too. And the piece that we really need, though, is to put the governance into practice. So at the design phase, at the engineering phase, in the product development cycle, how do you think about, and you've done this so well, how do you think about putting responsible AI in practice in product and engineering, since you know that so well?
Yeah, so one thing I've noticed as this landscape has continued to evolve, and a lot of people have been really interested, we talk a lot about governance, we talk about regulation a lot, and I think you might ask me a question about that later, but and these things are important, but by far and away, the most important part of getting the results you want from your AI systems is your design phase. It's your design and development. They have this term in InfoSec, shift left, right? So if you think of like a development timeline is going from left to right, you want to push your process, the way you're thinking about developing your systems, as far to the left of that process as you can, and you do it all along the way. And so the goal is not to develop systems and then try to govern them after they're developed. The goal should be for teams to be thinking about how to develop these systems in a safe way from the start. And I'll give you an example. So when you train models to do, let's say, recommendations of a certain type, and you're operating on data about people, let's say at Workday, we have a lot of resumes, right? HR software. Well, there's lots of things that could be contained in a resume that have very strong demographic correlation. They're not the demographics themselves, but they're highly correlated. So things like professional associations, what school you went to, your location, these are all highly correlated to things like gender, national origin, and so on. So you have to make a decision in the design phase about what you're willing to operate on with that data. Maybe you exclude it entirely. Maybe you're just very cautious about how you include it. And so that's something that would be done by the practitioner and the implementer. It's much better for them to be thinking about that when they're implementing the system than for somebody to try to test the system to see if it's got some kind of a bias in it afterwards. That's very tricky to statistically test AI and ML systems. They're non-deterministic. It's a very tricky process. And you'll never be certain. So you really want to be thinking about, how do I make this thing do what I want it to? How do I confidently and deliberately take risks where I need to take risks? And then as a result of those risks, what mitigation do I need to have at the end? And so I think that the whole idea of shifting it left is important. And it's really whoever's implementing it for you, whether it's somebody in your organization or a vendor or a partner that you're working with, that's really where they need to be. They're going to get the best results by the development team thinking about that. And what I can tell you as somebody who is a practitioner and implementer, almost uniformly, if you go to anyone, the other teams that we work with outside of Workday, our own team, almost everybody in the space wants that result too. So development teams, it's not as though the regulation is going to hem them in. They want regulation. They want regulation that enables innovation, but they want regulation. They also, in the absence of regulation, are going to be very, very thoughtful about how they do this stuff too. And that's kind of a general culture in the community.
Thank you. Yeah, shift left and think about important topics from the beginning. Moving to something a little bit different, you mentioned different kinds of large language models. A concept that we talk about is having an agnostic approach to large language models. And I kind of interpret that as, let's use what makes sense to build what we need for the right use cases. Can you tell us more about having an agnostic approach to large language models?
Yeah, so in one sense, we're agnostic in that we'll use whatever model we think is best. In another sense, we're not agnostic because we will use whatever model we think is best, right? And so we're not going to just swap models out for no reason. But there are many reasons why you want to have options in this space. And so at Workday, we do use third-party models. We use models from Google, OpenAI, AWS for certain things where that's appropriate. For most of what we do, we implement our own AI to do it. And we have multiple different models that we can use there. Now, there are many reasons. One is sometimes just a cost and efficiency thing like we talked about. There's also compliance concerns for us, and this may or may not apply for your organization, but we have data residency and so on that we have to deal with in a lot of cases. But putting all that aside as well, with the fast evolving space, you cannot count on any particular vendor being the same or even there in a while, right? So API are changing very quickly. You might want to have control of that. They may change policy around what they're allowing you to do. We saw this happen with the allowance of fine tuning, where it just became not feasible to allow fine tuning for a third party on models from some of these big vendors, so they stopped it. Right? API change frequently. OpenAI, as you probably all heard, almost died. Luckily didn't. So, when you look at that, you kind of want to have options open. And aside from the things I've just mentioned as well, it's a space where it's ripe for innovation. Like if you are working with a partner or if your own organization is doing it, you may make great discoveries in this space. And this has happened for us at Workday, working in the community of people who are developing and implementing. And it'll help you build up the skills in your organization to do this. Whether or not you're actually a direct part of implementing AI, you're going to be a part of it somehow in your organization by productizing it, figuring out how to apply it and where. And so another big reason to do this is that you develop the skills along the way.
Can you talk more about that piece, about being with that community where they're doing this, and just some of your techniques on how to do that well and how to work with different folks?
Yeah, for sure. One way that we do it, Workday has not in the past been a big contributor to open source. It's something we want to change eventually, but we haven't done that. So we've engaged with the open source community, which is one way. Another way is to work with vendors. So, we are a vendor and we work with a bunch of our customers. We're also a customer of companies like Databricks, for instance, and we work with their teams on it, AWS and Google. So essentially, you kind of identify people who have the bandwidth, the willingness to be able to work with you. And if you have, let's say, an enterprise system of record like Workday or Salesforce or something else, they probably have teams that would be excited to work with you as a customer. And so all of those are ways that you can do it. We also form sort of internal communities at Workday of people who are interested in particular topics and kind of enable them to have time and headspace to be able to think about these things and do research.
Thank you. All right, 2 more questions in our final 5 minutes. Thoughts on regulation. So right now, regulation is a big part of the conversation here in the US, the EU, and really around the world. And what kind of regulation, which bodies should be regulating, how companies should be involved in regulation. What are your thoughts on regulation in this space, specifically with AI?
Yeah. So I touched on it before. I think we want regulation that is bright line and clear, but that enables innovation. I think kind of as a society, we'll fall behind others who don't act too cautiously if we have regulation that inhibits innovation. And so we want to have regulation that's productive. The other thing that regulation can do, aside from inhibiting, is it can be ineffective in some cases. And I think, candidly, in the InfoSec world, some of the regulations that we have or some of the practices that are around that aren't actually productive. And so it's up to organizations to comply with those, but also do things that are productive. And that's kind of a double tax, right? And so I think if we look at regulation, it probably mostly should be around things that give transparency and visibility into what's happening. And when you do that, we can always look at anything new and evaluate whether or not that's something that, as a society, we think we should actually have, right? And so that's kind of our story. And as you know, we at Workday, we do have some public policy people who are dedicated to this, and a bunch of other companies do as well, and are forming alliances to try to get us to the point where the product side of this is considered alongside the compliance side.
Yeah. Thank you. A big call to action for those who want to be involved in policymaking and regulation to be in the room to give feedback so your respective governments everywhere can make smarter regulation. So our final question today is around implementation. The big, I think, question for a lot of enterprise companies is, how do we do this? Do we build something in-house? Do we hire our own software development, ML, et cetera, teams? Do we buy solutions that offer this in some way? What are some of the tools that we have available and techniques to think about how to bring generative AI into our companies?
Yeah, so in my opinion, the best way is something that uses almost all of what you just described, almost all those tools. If you already have partners, if you're a customer of a company that is doing this at scale like we are, that's a great place to work with somebody. Building your own team, to me, is a question that really it's going to vary a lot by organization. It won't make sense for every company to build an AI machine learning team. You're probably going to have somebody who's leading that, but they might be more of a product contact who's figuring out how is this implemented inside the organization, but it's being done externally. I think for some organizations, it will make sense to build your own team and do a lot of what I was talking about before and build those skills up over time. So really, like a multifaceted approach is probably the best way to do it. And I do think that more and more, your data, whatever data you have in your company that's proprietary and for you, is something that people outside of IT or outside of your technical teams need to understand. A lot of times you have very high level understanding of data, but getting down into a little bit more detail, like what's actually in a data set. I used to work at Nike, like you mentioned, right? And the business folks at Nike, which I was a business person at Nike, but I was also a technical person at Nike. So I was one of the people that sat in the middle. And the pure business focused people would say things like, hey, we have purchase data for all our customers. And it's like, yeah, that's true. We do have purchase data and history on all our customers, or at least all our members. But what's actually in that data, right? If I go and look at a row in that table, what's actually in there? The more you know about that data, the more you might have ideas about how it will be applied in product, because a data scientist who's analyzing that isn't going to understand the product side of it well enough to figure out, oh, wow, this is correlated across these two data sets. I have purchase history. I also have seasonality trends in here that we should implement in this part of the product, or regional trends that can emerge. So like getting more familiar and closer to the low-level data sets that you have, I think is another step that you want to do.
Thank you. I know I said one question, but I do have one more, so we can wrap up. What do you think is one of the most promising things about generative AI, large language models right now? What gets you really excited about it?
Yeah, we've never seen long-form natural language output from models before. This is new in the last year plus. So we couldn't do anything like what you see ChatGPT doing when you play with it now. That's all brand new. And it works. We've proven that it works. And we've proven that it works even with much smaller, more efficient, more tractable models. We're doing that stuff. And so this huge area, which comes fraught with some difficulties too, IP concerns, obviously all the stuff that we didn't talk about IP, we talked more about like model outputs. But at the end of the day, that's all there. But we've never had models that could help us do these things before, in image generation, in code generation, there's in decision modeling and scenarios. Like it's amazing what we have. And so you have, and also the velocity that we have from like the entire power of the community of people who are implementing this. I was talking earlier about the history of AI and saying, hey, between 1960 and the late 90s, there wasn't that much. There were like a few people working on it in the world, right? There weren't that many people doing anything with it. We've got tens of thousands of highly skilled people that are all contributing daily to this this particular area. And so it's created a tremendous bow wave that you can ride as an organization. It's a little scary because it's a big wave and it's moving really fast. But if you can ride the wave rather than get overwhelmed by it, I think that opportunity is tremendous.
Thank you. Thank you all for joining us. As Shane Luke, our head of AI and machine learning, with over 20 years of experience sharing. Thank you.